Math was the one subject that I struggled with so badly growing up, especially in college. And by the way, Judy identifies as an ENFP. And so this is also something that might be interesting. This is not an INTP mathematician here or some mastermind INTJ, but Judy is still a mastermind in my opinion, at least. And yeah, it was just interesting to see like the fun way that she was able to actually depict the different ways that functions may be able to learn and be able to approach math, and then how different types will be able to see the value in it. And she has a patience to her, a gentleness to her. And she's able to really bring a refreshing way to actually come into math.
A little bit about myself. So I am originally from Austria. At the age of, I want to say 18 or 17, I'm really bad with those kinds of things. I decided that it was time for me to leave Austria. So I moved to South Africa on what was supposed to be a gap year and turned out to be an over a decade long stay. And I decided to study math there, do a PhD there. More out of coincidence than because I planned it. I started studying music actually, and I needed an extra credit, and math just happened to fit my curriculum. So I took it, and turns out math was more fun for me than music. So changed majors, stuck with it. I realized that, like you, Denzel, funnily enough, most people are not too fond of math, which hurts me a little bit. Not just a little bit, hurts me down to my core, because I think most people could really enjoy math. I think there's a lot of people that have been hurt by either other people or by the way math was taught to them that really didn't serve them. And that's one of the reasons why I wrote my book, in order to help these people actually maybe fall in love with math, but for the very least get over their fear of math and help them no longer be blocked by whatever math has been blocking them from doing. I've had by that time a lot of conversations with people who, upon hearing that I'm a mathematician, immediately are like, oh, wow, I always hated math. Mainly because at that time I did a lot of popular science talks. I was traveling all around Germany and countries to give talks, to do short math stand-up skits, stuff like that. And so I was traveling a lot, and I usually had like a huge triangle with me because that was part of my act. And then people were like, oh, what do you need that triangle for? And crowd the whole train with, essentially. So I had a lot of conversations with people on trains, and I had particularly that conversation over and over again, where people just kept thinking of themselves that they are really, really bad at math. And not only is that sad for me, because I draw a lot of joy from math, but just my scientist brain thinks, statistically speaking, it's unlikely that many people are really actually bad at math. So I kept thinking about it. Why do people think they're bad at math? What is it that is keeping them from accessing what math really has? And at some point, I just had so many thoughts, I needed to write them down. The beginning, I didn't think it was going to be a book. At the beginning, it was just like, okay, like other people journal, you know, just to sit down and write it all out. But eventually it became clear that this was a lot that I had to say, and it actually became coherent in some ways. So I thought, okay, I'm this close for it to being a book, may as well shoot for that now. And then came another 2 years of like editing, beta reading, the whole lot that goes into actually having a book from having a first manuscript. But that's how it started. Basically, what I would love for people to get out is, if they had any sort of negative experiences with math that made them feel less about themselves in any shape or form, like made I can't do math, or I'm not good enough to do math, whatever it might be, that I hope that after reading the book, thinking that not that you are not good enough, or not that it's lesser, or you're less in any way or something along those lines, but rather that you think of yourself as someone who can do math if they choose to, and that maybe you can even find some joy in pursuing math further.
That's beautiful. What's up, everyone? If you do not know me, my name is Denzel Mensah. I'm an ENFJ, 9-wing-1, social sexual in the Myers-Briggs and Enneagram system. I'm also a certified life, personal development, and relationship coach. And today I'm here with my friend Judy, who has written a book on math and typology together. Essentially, I would say we're going to go a lot more about it, like more into what that might be, but I wanted to give her the opportunity to be able to talk about this new book. I was actually part of reading it and letting her know like what I thought about, especially a specific chapter that had to do with, you know, how different personality types may approach or learn about math. And being that I am somebody who math was the one subject that I struggled with so badly growing up, especially in college, then reading the book was like, Judy knew that I hated math essentially. And for Judy being somebody who loves math, and by the way, Judy identifies as an ENFP. And so this is also something that might be interesting. This is not an INTP mathematician here or some mastermind INTJ, but Judy is still a mastermind in my opinion, at least. And yeah, it was just interesting to see like the fun way that she was able to actually depict the different ways that functions may be able to learn and be able to approach math, and then how different types will be able to see the value in it. And she has a patience to her, a gentleness to her. And she's able to really bring a refreshing way to actually come into math. I once told her that she reminds me of the teacher in Dead Poets Society, who I also thought was ENFP, except, you know, in this case, it was more about math than poetry. So with all of that said, Judy, do you mind telling us a little bit about yourself and then what brought you to also writing such a book?
Sure. So my name is Judy. I'm not going to bother you with my full name because it's German and hard to pronounce, but I am sure Denzel will write it somewhere if you're interested.
Right.
A little bit about myself. So I am originally from Austria. At the age of, I want to say 18 or 17, I'm really bad with those kinds of things. I decided that it was time for me to leave Austria, so I moved to South Africa on what was supposed to be a gap year and turned out to be an over a decade-long stay, and I decided to study math there, do a PhD there. More out of coincidence than because I planned it. I started studying music, actually, and I needed an extra credit, and math just happened to fit my curriculum. So I took it, and turns out math was more fun for me than music. So changed majors, stuck with it. Have been a mathematician pretty much ever since. After I finished my PhD, I went back to Europe. I did a few postdocs. For those of you who don't know, that's essentially a research position at the university before you have a tenured position. So
I totally knew what that meant.
Sorry?
I totally knew what that meant.
Oh, yeah, for sure. That was for some people like me who before they went into academia didn't know. But eventually I decided that it was time for me to leave academia and actually focus on science communication pretty much full time. And I realized that, like you, Denzel, funnily enough, most people are not too fond of math, which hurts me a little bit. Not just a little bit, hurts me down to my core, because I think most people could really enjoy math. I think there's a lot of people that have been hurt by either other people or by the way math was taught to them that really didn't serve them. And that's one of the reasons why I wrote my book, in order to help these people actually maybe fall in love with math, but for the very least get over their fear of math and help them no longer be blocked by whatever math has been blocking them from doing.
Yeah, and I think that that's you have a purpose in this world that is extremely important. And I'm saying that with like a laugh and a smile and everything, but that's actually something that I really find to be serious, because you guys don't understand that like math, like to be a little bit vulnerable. Like I had failed. That was the only class in my undergrad that I had failed twice. Well, just failed in general, but then, you know, failed like we had to take 3 math classes for my undergrad, and first time I took it, failed it. Then I passed it later on, and then I took the second one, like the level 2 one, almost failed that. No, I failed that one, and then I was just like, okay, it was just so much. And so to have someone who's actually like, hey, like I am not only good at math, I'm not only also good at teaching it, but I want to be able to try and find a new, refreshing, novel way to be able to not only teach math, but then also meet people where they are when it comes to like personality type or, you know, whatever it might be, so they can understand math from how their mind is wired. I think that that is absolutely beautiful. And I think that that's, you know, even more of a reason why to, you know, encourage reading this book. And so, yeah, what made you then decide like, okay, I'm actually going to like make a book out of this, like, and just follow through this process?
I've had by that time a lot of conversations with people who, upon hearing that I'm a mathematician, immediately are like, with, oh, wow, I always hated math. Mainly because at that time I did a lot of popular science talks. I was traveling all around Germany and countries to give talks, to do short math stand-up skits, stuff like that. And so I was traveling a lot, and I usually had like a huge triangle with me because that was part of my act. And then people were like, oh, what do you need that triangle for? And crowd the whole train with, essentially. So I had a lot of conversations with people on trains, and I had particularly that conversation over and over again, where people just kept thinking of themselves that they are really, really bad at math. And not only is that sad for me because I draw a lot of joy from math, but just my scientist brain thinks, statistically speaking, it's unlikely that many people are really actually bad at math. So I kept thinking about it. Why do people think they're bad at math? What is it that is keeping them from accessing what math really has? And at some point, I just had so many thoughts, I needed to write them down. And at the beginning, I didn't think it was going to be a book. At the beginning, it was just like, okay, like other people journal, you know, just to sit down and write it all out. But eventually it became clear that this was a lot that I had to say, and it actually became coherent in some ways. So I thought, okay, I'm this close for it to being a book, may as well shoot for that now. And then came another 2 years of like editing, beta reading, the whole lot that goes into actually having a book from having a first manuscript. But that's how it started.
Makes sense. And just for those who might have not seen the picture when I put it up, the book is actually called Math Reimagined, How Math Was Meant to Feel. So with all of that, in this video today, we're going to go into how different functions approach math. And we're going to be, you know, spitballing and discussing like how that might be and how that could also fall into different types and how they might approach math as well. And so I guess we're going to start with the perceiving functions, because we're going to be talking more about like how a function might learn. And then from there, Judy's going to workshop with like, okay, based off of how this function learns, this is how a function might be able to approach math. And so if you have this function, then it might be able to help you out in that sense. And I think the first function that we're probably going to start with is SE. SE, extroverted sensing, is in a nutshell all about what is empirically in front of us, a unified reality. It's usually about, you know, it has a keen eye oftentimes for aesthetics. It's a lot about jumping into action and essentially just being able to learn in the actual experience itself. And so I think that one of the ways that SE learns best is that, okay, I see SE kind of like when eagles are dropping their young from the nest, and then once the young is like falling, then the young has to learn how, the eaglet has to learn how to fly while falling from the nest. And, you know, of course, if they don't know how to fly, like if they don't like catch it by the time they're about to hit the ground, then the mother swoops down, picks them up, puts them on the nest again, and then pushes them off again until they get it down. But yeah, essentially SE / extroverted sensing learns by doing. And so while it's in the midst of actually being in the midst of the situation, like it's able to now see like, oh, okay, this is what's going on over here, this is what's going on over there, this is what's about to be happening in this sense. Okay, now I'm assessing this situation, or I'm experiencing it in real time, and then it has an instinct almost of what to do in that sense. And that's how it's able to oftentimes learn, because it's like, okay, it's learning while in it. I think that's like the biggest thing that I can put there. So based off of that, Judy, how would you say that extroverted sensing / people with extroverted sensing in their function stack might approach math? And that's, for those who don't know, ESFPs, ESTPs have it as a dominant, ISFPs, ISTPs have it as an auxiliary, ENTJs and ENFJs have it as a tertiary, and then INFJs and INTJs have it as an inferior function.
So I understand that math, on account of being rather abstract, may not, on first glance, appeal to SE per se. However, that being said, math does speak about stuff that's usually high in like patterns, aesthetic stuff like that, and you can picture these things. Starting off with geometry, right? When we speak about a sphere, why not actually pick up a literal ball or something and figure out how that works, instead of learning that the circumference of a circle is this or that? Take a disc. For those of you who are my generation or older, you may still remember CDs, and actually try to measure it and see how the circumference is really in relation to the radius, stuff like that. I remember during my PhD, I was working on this one problem where I had to picture higher dimensions in some way or another. And one way to picture it is as multiple copies of our current dimension. Not going to go into in much detail. Read my book if you want to know more. But yes. What I actually did, what I did is I ordered several hundred, I want to say 700 almost, of like little wooden cubes, like 2 by 2 centimeter cubes. And I just built the things that I was picturing and built several copies of it, and literally had it in front of me how that could manifest as a higher dimension. So I was building the physical stuff because it does really help. If you want to know more how to use math tools, there's, I don't know whether Montessori is a thing in the US.
I've heard that word before.
Okay. It's essentially, it has to do with education and people educating other people with like new ways of going about it, whatever. But there are Montessori tools for teaching math, which are literal physical things that you can use to picture concepts more clearly. And I'm a big sucker for that. I've spent a lot of money on this because I love just seeing how concepts can be pictured with physical things.
Got it. Okay, so then if I'm understanding correctly, the way that SE can approach math is, I guess it's kind of like there's a scene in this movie called Like Mike. It's actually one of my favorite movies, and essentially the movie is funny enough. I believe the main character in the movie, who's played by Bow Wow, Lil Bow Wow at the time, was an ENFJ as well. And the movie is pretty much about this orphan boy who finds this Michael Jordan's old pair of sneakers, and it gets struck by lightning. And because of that, then the sneakers make it like become magic. So now he's able to play basketball at like Michael Jordan level, even though he's a very short, young orphan boy. And so he ends up playing in the NBA, and then things start happening from there. And then in there, there's a scene with him and this ISTP. Like the ISTP is like the best player on the team, aside from Calvin. That's the main character's name. And he goes over to the ISTP's house. The ISTP's name is Tracy. And he tells Tracy, like, yeah, man, like I need some help with my homework. Like I hate math. I just don't get it. And I'm like, I think this is common for ENFJs. And of course, there's probably going to be some ENFJs like, oh, actually, I love math. I'm like, you were one of the lucky ones. But pretty much he tells Tracy, like, yeah, I hate math. I don't get it, whatever. And Tracy's like, oh, yeah, no, I got you. And one of the ways that he helps Calvin with his math is that Tracy goes out and he paints like the different triangles on the wall. And so when he paints the different triangles on the wall, the equilateral, the isosceles, and the acute triangle, then he has a different player on each side or each corner of the triangle. And he's pretty much saying like, okay, so this is, this is a triangle here, and they're using this for, I don't know, like Kobe Bryant's team, like with the Lakers, because this is an old movie at the time. And so then he's like asking Calvin, like, so what do you think that they have to do? And then Calvin's like, okay, well.
You know a little something about geometry?
Do I know about geometry? Do I know geometry? Take your time on that call and meet me outside. I know geometry, but. Okay, now the key to the whole geometry thing and getting the hang of these triangles is to supersize them.
Supersize?
Supersize.
You painted your house.
All right, now come on. Tell me what triangle this is right here.
I'm not familiar with this one. I don't know.
All right, let me give you a hint. So you got MJ over there posting up the small point guard, right? You got Robin over there on the other side of the court with his hair. Now Pippen comes just a screen from Michael. So what do you got?
Well, this is the Bulls triangle offense, right?
Right.
So we're just giving room for Michael to isolate. Isosceles. An isosceles triangle.
Exactly.
The Lakers use this triangle offense. This triangle has equal sides for Kobe and Shaq. Equal sides. Okay, this is an equilateral triangle.
There you go. So you're getting it. You're getting
All right.
it. Okay. Okay.
All right, wait, I got this.
You got this one?
Okay, now this is us.
Uh-huh.
And the type of triangle offense we use is the acute offense. Well, the acute triangle offense.
Okay.
That's because Calvin Cambridge is so damn cute.
Oh, man, give me a break. I'm the cute one.
No, I am.
No, see, look at the picture. I'm the cute one.
No.
Okay, go ahead.
Check it out.
All right.
All right. So, okay, see, here's Joe, right?
Right.
This is Joe.
Uh-huh.
Joe's gonna take the ball out, and he's gonna pass all the way to you.
Okay.
See, you're right here.
Right.
See me? I'm gonna be heading down court for the full court lob pass, just like this, right here.
Okay, Calvin, don't put paint on my windows, all right?
But I'm gonna be wide open.
Calvin,
You gotta pass me the ball.
I'm warning you, all right? Don't do it.
And then, wham! 2 points for me, and the assist to Rick.
And I guess this is leaning a little bit into the NI that we're about to talk about as well, because SC and NI, introverted intuition, always come together. So the flip sides of the same coin. And I guess just to kind of bleed into that a little bit, introverted intuition is all about pattern recognition in the sense of the mind. So I'd say that it's metacognition. It's if extroverted intuition, which we're going to talk about later, is about thinking outside of the box. Introverted intuition is thinking about the box. This is where you get people who are thinking about life in general, like Plato's allegory of the cave. Like, okay, life itself, like, are we in a simulation? Are we not in a simulation? Like, what things are spiritual? Like, how are we perceiving reality? And then introverted intuition is also about like, okay, using extroverted sensing to assess the situation right now. How can I now see past that to see what's coming up forward? Like if the hockey puck is right here, extroverted sensing, where's the hockey puck about to be in the next 5 seconds? Or where is society about to be now that we have AI doing this right now? Where are we going to be in the next 5 years due to like how things are looking like right now? And so the right now is the extroverted sensing part of it, and then the introverted intuition part of it is the projecting or future trajectory, looking forward, and also looking at things beyond surface and the meaning of it all. So back to Calvin Cambridge with the math things. The reason why I bring that up is because he started to understand it more once Tracy put the SE of it like right physically in front of him instead of just a triangle on the page or whatever. He put the triangle like really big, like he painted it on the side of his house. And then he also added a concept to it, the introverted intuition. Like, let's put some meaning behind this by adding, some of the basketball players and stuff, like a concept that you're familiar with. And then let's see if you're able to now connect the concept with that. So yeah, once again, in my opinion, that's like combining the NI and the SE. But with that said, NI, again, like learns, in my opinion, from being able to actually pattern something and like predict something and then see like, okay, am I going to be right about this? Based off of what's happening right now in this movie, then if I were the writer, then I would probably have the movie end like this. So now let's see if my prediction is right. Oh, okay, this is where I was wrong, so let me tweak it a little bit. Oh, so I was right. Let me see how frequently I'm able to actually nail this and what made it right. That's how I think that NI is able to calibrate their intuition based off of all of the people that I know. This is a pattern that I've seen in relationships or something. Let's see if I'm right about the trajectory of this specific relationship of this ENFP and INTJ getting married together. Oh, turns out that I was right with how things are going right now, and boom, 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 boom. So I'd say that that's how NI works. It's kind of like, oh, let me predict based off of what's happening right now, which the happening right now is always the SE, and then see if I'm right about the trajectory that I'm seeing forward, or the meaning behind what I'm putting behind whatever is there. And so with that, and I guess, you know, having just said my example, I know I just said it a lot, but do you have any commentary on how NI, or even adding on to the whole SE usage of that with math?
So I actually want to add on a bit with SE, because I think you brought in a great example there. And I think especially for SE, it's very helpful, if possible, to tie whatever concept is, not just to maybe the physical thing that explains the concept, but maybe to a real world application or situation that they might be familiar with, or if they are not personally familiar with, that they at least can see the point in it.
Yeah.
So
that definitely works for me. Yep.
Yeah. I mean, there's one thing about learning about vector calculus and what vectors are. It's a whole other thing if you think about it as coordinates on a grid, and how that may help you with navigating around the globe, for example. That's essentially the same math that goes into it. But the one thing is very abstract. And even if you draw like the arrow, that already helps, you know, to just see it physically and not just have the concept. But tying it to something that is maybe applicable to you, which I would imagine a lot of SE people quite enjoy, maybe tracking around the world and figuring out coordinates, I don't know, then that gives it another meaning to it, and maybe even more motivation for you to learn it, because you now can see the application in your life.
Yeah, I think that that's actually spot on. Whenever I was able to actually see how, oh, this is actually going to be helpful for me in, you know, in the future, which I guess also, again, kind of goes back into the NI of it. But like, yeah, like seeing the practicality of like, oh, this is not just literally theory. This is something that, like, yeah, if I go to the grocery store, I'm going to need to know, like, okay, how to make $1 out of dimes, you know? So like, let me like learn this kind of math or whatever like that. And obviously that was not the math that I was failing in college. But yeah, things of that nature, even, you know, thinking of like things like the Pythagorean theorem, I was often thinking like, okay, like this is not something that I feel like we would actually be using in real life and all of that. However, in one of my classes, the last classes that I was taking in my undergrad, it was interesting to see how they were using it in a way where it's like, okay, you have there's like a flagpole, and then the flagpole is casting a shadow. And so by using how tall the flagpole might be, and then how like long the shadow might be or something like that, then you're able to, now you have to like do a squared plus b squared equals c squared. It's able to see the hypotenuse of like how far the shadow is, like where it starts to like the top of the flagpole, something like that. And they would sometimes even do that like with a ladder. Like, okay, like if the ladder is like moved on this way, and then the building is like this, something like that, then you're able to now see like, okay, the certain measurements, you're able to actually like gain the measurement if you know how long one part of the triangle is and the other part of the triangle. And when it was presented to me in that way, then I was like, okay, it even motivated me more to be like, okay, like let me really try to grasp and understand this, so that in the future I'd be able to actually okay, wait a minute. Like, for whatever reason, if I want to know the length of a flagpole, let me let me apply this.
I mean, it may just not be the length of a flagpole, but that's essentially how geolocation works. So if you have your satellites that are like going around the Earth and so on, and you're trying to figure out where you are, essentially they're saying signals up, signals down, and they're using exactly that math. They're using trigonometry to figure out where you are and how you can pinpoint things and stuff like that. So you can really bring it back to the real world, how you figure out at which location you are in this world. So it does have real world applications, and it might be fun for you to figure that out and know that. And if you don't have cell phone signals and you have to try to figure out where you are or how far you're away from a certain point, just using an app, that's exactly the kind of stuff you would be doing.
Wow. Yeah, I definitely had no idea that Pythagorean theorem had to do with geolocation. So that makes a lot of sense. So then tying that in with introverted intuition, how would you say that you've seen introverted intuitors use math or like approach math?
In that, I think there are a lot of facets to it. On the one hand, and I like to go deep, right? So for NI, it will not be sufficient to learn what is the Pythagorean theorem and then maybe figure out that, yeah, okay, I can determine where I am on the world with it. I mean, that will be nice, but that's not sufficient. I think NI will have to dig deep and figure out, okay, but why does the Pythagorean theorem work? So for NI, it might actually be helpful to read proofs on these sort of things. And I know that sounds scary, but a proof is not something to be afraid of. A proof is essentially just a fully fleshed out argument that tells you why something is true. Yes, there are some proofs that are very, very short and written in a very concise way. Those are not the ones you want to be looking for. You want to be looking for the ones that are longer, because then people have really written out the steps and it makes sense to you. Also, as far as I understand it, and I think that's something that maybe NI and NE have in common, NI likes to think about how a mind works and how other people's mind works. And essentially, if you read someone's proofs, you're figuring out how a person thinks about the concept.
Yes.
And that to me is super interesting when you realize, oh shit, that person made that connection. That's how their mind works now. I'm learning something about not only them and their mind, but also I'm putting a little thing in my own toolbox. You know, if you can think about that concept that way, because they just showed me that I can, maybe I can think about other concepts in that way too. And that may be like really fun for NI to think about it that way, as in, no, this is not just a logical chain of arguments. This is how someone's mind thought about something. Yeah,
I definitely agree. Like knowing, I always talk about paradigms. And so understanding like how somebody is perceiving the world, approaching the world, why something is appealing to them in a certain way, or why they're drawn to a certain thing versus why maybe other people might not be, or why they are deterred from something, why they struggle with something versus why other people might not be. Like things of that nature. I think that that's definitely a huge thing for NI. And yeah, you're right. Like, you know, and again, it kind of goes back to the whole thing about how NI and SE come together, because seeing the proofs of it helps NI to be able to be like, okay, this is proof of SE reality being seen like correctly. Like, okay, like this, like my theory is a squared b squared is equal to c squared in all of these situations. But why does that work? I have to see if this is really true about reality. So in order to see if this is really true about reality, since it's in theory right now, then let me look at the proofs of people who have actually been in the experience, SE, to be able to like test it. And then, you know, they, I guess, recorded that information, which I guess now goes into SI. And so SI is the function that's all about consistency. It's looking for things that are stable. It's looking for what is reliable. People often say traditional, and I don't disagree with that, but it could also be something that turns people off, like that word. So what I'm really trying to look for is like, I think reliable is the best word. Like, what is the most reliable method? Like, your grandmother and your grandmother's grandmother and her grandmother's grandmother have all tried this, and it's always worked. And that's why we keep on passing it down and don't make any modifications to it, because then we cannot assure you that this will work. And obviously that is handy when you're looking for something that's pretty much 100% guaranteed. SI is the function that you want to look to. That's not the time to start trying stuff out like maybe NE might want. But yeah, introverted sensing is all about like that stability, that consistency and everything. And so when you have, in my opinion, like all this recorded data of like, okay, this is what happened when we tried this math experiment. This is what happened when this happened. All of these records, I think that that's, you know, like where SI comes into play. And going into how SI learns, I would say that SI learns by really watching certain things happen over time and seeing what has been consistent, what has been reliable, what has been essentially like always has always worked, what has been reliable and consistent. I think that's like the biggest thing. And then it's able to be like, okay, let's replicate that and let's continue to replicate this exact thing the best that we can. Do you have anything to add to that, Judy? Especially since that is in your function stack.
Sure. I will cycle back to NI once more though, because I thought of something. And seeing that NI also likes to dig deeper on concepts, I think NI people might very much, or NI users rather, not NI people, might very much enjoy the philosophy of math and really thinking about what actually is a number. And I mean, yes, we all have a working understanding of 2 means 2 things, but what is 2? The concept. It's not like something that I plug off a tree. What does it actually mean? What does it mean? Real stuff like that. And you can learn a lot of math just by thinking about these concepts, because you learn how those concepts actually shape out in math, if you will. But okay, going to SI. So I think you said something interesting, which is math experiment, which doesn't per se exist. There is no such thing as an experiment. That's physics. In physics, you have to do experiments and then figure out whether, you know, your theory matches up. Math has the wonderful advantage of having absolute truth. You don't need an experiment, because once you've proven it, it's proven for all things, for all time. So it's not going to change. It's always going to be true. If you think about it, if, for example, you know that a number is even if the last digit of that number is 248.
Right.
That is not something that you have to experiment on over and over again. You will never, ever find a number that is even that does not have that as a last digit. And any number that has that as a last digit will be even, always, because there's a proof. So you don't have to experiment on it. It's just true. And that's something I think that is very, very appealing to SI, because it's not something that you have to refine over and over again. Once it's done, it's done. The math that has been done 2,000 years ago continues to be true to this day. It doesn't have to be refined. It's just as true as it was then. And therefore, it makes sense that we still learn about Pythagoras and all of the things that have been long before us. Because unlike physics, where our understanding of the world keeps evolving, and maybe the old physics, or it wasn't per se wrong, but we know that it was only applicable in certain instances, or we didn't have a full understanding of it, therefore we now teach it differently. That's not true for math. It's just true. And that's something that's very nice in SI, that you can rely on the fact that what you learn now, you don't have to keep updating. It just keeps being that way, and it keeps being true that way.
I think that is very, very like interesting. And I can definitely see now like how that is the case. Like, yeah, like once something has been shown in math, then it is applicable in pretty much every other area. Because yeah, that is something that's like, what if you know that an even number is at the end of what, no matter how large the number is, like if the last number is an even number there, then it's like, okay, then this is able to be evenly split. And that, yeah, that is an absolute truth. That actually, that's a pretty cool, I don't know if I had processed that was a thing. especially when you said like the experiment thing. It's like, oh, but yeah, that makes a lot of sense.
Yeah. Also, I think SI is a function that will benefit a lot from just doing lots of examples, repetition, basically building up that memory from which you can draw, that gives you the comfort in knowing that that is how things work. Just, might not work so well for other functions, although there is, of course, something to be said for repetition and exercise and, all of that. But especially for SI, I think that will work quite well because it gives you comfort just to keep seeing that it will work out. It always has worked out. It will continue to work out.
That makes complete sense. So then from there, if we're throwing an E into the mix, which is the other side of SI, and I know that you're absolutely not familiar with NE at all.
Not at all, not even a bit.
Extroverted intuition is the flip side coin of introverted sensing. So if SE, extroverted sensing, is the flip side coin of introverted intuition, let's say SE is all about being here in the moment. It's all about seeing things concretely for what it is. It's about being in the experience. Then NI is about being in the future. It's about looking at the meaning behind the thing. And it's about projecting like, okay, what's going to happen and looking deeper behind like what's just right in front of it. So with SI, if introverted sensing is all about what's reliable and what's consistent and what can be replicated and all of that, and how can we keep things like as the status quo and like just always like, not changing it in a way, then extroverted intuition is all about essentially breaking that consistency in that pattern to look for another way to have the thing become consistent. Like, okay, yes, it's always consistent when we do it this way, but let's find other ways for this to be consistent. Like, okay, let's explore how else we might do this or how else we might do that. And let's see if that kind of like comes in this way, which it's funny because now I'm being careful not to use the word again, like experiment, because to me, I guess it kind of sounds like NE is like, well, let's experiment. Like, let's try doing this math problem this way and let's see if that works. And oh, it worked. And so therefore, this is another way that we can like do this math problem. Unless maybe we have to do it again with different math problems that are similar 4 more times to see if we get that consistent and reliable thing. And then that NE becomes the new SI. That's how I'm seeing it. But what would you say about that? And if there's anything I've missed about the function?
So NE is all about exploring, like you said. I think there's a lot of similarity to SE in the sense that SE needs to sort of grasp math quite literally. NE also does need to do that, but less so with physical tools. Although, like I said, I also have lots of stuff that I can physically touch because it helps. But more along the lines of, okay, I see how this concept works in this way. That has been proven, also my eye remembers that is how the way it's done. But what if I tweak it a little bit? What if, for example, Pythagoras tells us, like we said, if we have a right-angled triangle, a squared plus b squared equals c squared. There's my right angle here. What if I don't have a right angle? What changes? What breaks? Why does it break? Can I find a new pattern that helps or that emerges in that situation? What is similar? What changes? Things like that. Go away from the things that you know and see whether you can find new patterns, see where the old patterns break and find out why they break. Essentially, that is what drew me to research in math, because that's what you do. You build up of the already established theorems, and now you're trying to figure out, what if I go beyond that? What happens there? And sometimes you run into problems that are just not solvable. And that's okay, because NE is about exploration. The fun is, in the journey, not necessarily in the result. But often you also run into things where you find out completely new patterns and how they work. And that's just so satisfying. You figured out a new pattern, and all of a sudden you may be like, oh, but maybe I can draw from this completely unrelated concept in math that I know, but I seem to see the same patterns that are present there. Maybe I can connect that, and maybe I can actually apply what I've learned here to this situation. So it's literally about connection and figuring out how certain things that you learn in possibly completely unrelated part of the toolbox may apply to this here. So to the NE user, I would also recommend maybe getting books on math riddles, and just that helps you explore for yourself and not just go through the things that people have done, although that will be beneficial to you because it is improving your toolbox, and it's something that I've done way too little in my own math career. But you will strive, or you will basically go into your own if you try to figure things out on your own and try to find your own patterns.
That was very beautifully explained, and I now also understand even more like how, my mind is conceptually grasping how, NE does work in that sense. And I like the example that you gave, okay, well, what if there isn't a right angle? That really does, because NE really is all about, well, what if, and then seeing okay, if from kind of understanding the what if, now where do we move from there? So that's definitely interesting. Is there anything that you would say you'd like to add about the 4 perceiving functions before we move to the judging functions that we might have skipped?
I think mostly the perceiving functions are about how you learn. I think the judging functions is more about how you make it interesting to you.
Okay. Well, then in that case, I guess, now we're about to talk about how math can actually be interesting to you as a person, which I'm definitely interested in hearing about that. So with that being said, the first judging function that we can hop into is extroverted thinking. So extroverted thinking, also known as TE, is a function that is always looking at the effectiveness of something. What is the most efficient or most effective way to be able to carry out a task? Extroverted thinking is always asking what works, what does not work. If it doesn't work, we discard it, or we might, we're basically looking for the way to get results in the real world. We're basically looking for a way to, the best way to be able to get from point A to point B, and it's all about benchmarks. And the flip side coin of extroverted thinking is introverted feeling, which we're going to be talking about next. But when we're looking at how extroverted thinking learns in a way, then extroverted thinking, from my opinion, is learning by looking at the weak points and the strong points in the system. And so when extroverted thinking creates a system of some sort, then it's okay, this is where the system is most weak, and how can we strengthen those weaker points in the system? And then this is where it's most strong. How can we even make those strong points more strong, or develop the system to become even better in that sense? So with that said, how would you say that extroverted thinking makes math more interesting / people who have extroverted thinking as a function, it's more interesting to, math becomes more interesting to them?
Well, for one, like I said, math is about finding patterns. And essentially that's what a formula is. It's a condensed way of writing down a particular pattern that you see. The a squared plus b squared equals c squared is literally, you take the length of that thing and the length of that thing, and then you know that the length of that thing is related by that formula. If you didn't have that formula, you would have to calculate over and over and over again and go through the reasoning as to why this is true over and over again. So math provides you basically a shortcut way of getting there. So if you think about it that way, it's very efficient for TE to think about it, math, as giving you a shortcut of getting from where you want to be to where you need to be.
Yeah.
Because you don't have to go through the reasoning all over again and think about the reasoning. You do it once and that's it. That's the way to go about it. I think for T, it's also beneficial to think about what is your reason as to why you want to learn math. Are you interested in financial math? Are you interested in economics? Are you interested in learning how to build a shed? I don't know what it might be, but find the math that relates to what you're interested in so that you can find a streamlined path towards your goal. Because to T, it kind of is super annoying when you meander around the point for ages and you don't see why the heck you need to learn this, because sometimes you don't, but rather be sure that you find the math that is relevant to what you're interested in. And I think T will also find a lot of beauty in maybe experimenting with math, in the sense that finding maybe an even better way of solving the problem. The way you have learned may be a very long route, but this may not be the best and most elegant path to get there. There may be a much shorter way. And so that may actually make it fun for you to, play around with math a little bit and find whether there's a much more streamlined version of doing what you need to do.
Wow. Okay. Yeah, that makes sense for sure. And for later, I'm definitely curious to know like what makes a formula TE and not TI. Or I could even see it like being like sometimes. Well, I was thinking like it could possibly also be SI in certain ways, but I really don't know. So that is definitely a question that I guess when we get to covering TI, I'm going to try to remember to bring back up to you, because I'm very curious to see like, or unless if maybe there are different ways of like formulas like showing up and everything. But yeah, that makes sense. And did you have anything else to add to that, like before we move on to FI?
I think just for T, the point is make sure that you are reaching your goal with it. Don't just go into math for like exploration, unless you're also an NE user and that's higher for you. Then it's fun, But if you're a high TE user and maybe NE lower down or whatever else you might have in your function stack, make sure that you start with the goal. It may also be very helpful for you to maybe keep track of the points that you need to learn in order to get there, how they relate to each other, just so you can sort of have an overview. T always likes to have the big picture view of things, not to go into the nitty-gritty too much, but sort of have, okay, first I need this, then I need this, then I need this, then I need this. I sufficiently understand how they relate. That's good enough for me. I now can go the entire way. I'm happy with this.
Makes sense. Totally. And so with goals, I would say that's also linked back to FI, because FI, if we had to think about desire, I think that FI, I wouldn't say it has the monopoly on what desire is for like every function, because every function might in and of itself have a certain type of desire. Like SE has a desire of experience, NE has a desire of novelty, FE has a desire of like connection, whatever. But when you're thinking about like, okay, what is it that I want as a person? Who am I as a person? What are my values as a person? What do I feel as a person? What like my identity, stuff of that nature. That is all introverted feeling territory, which is the, again, flip side coin of extroverted thinking, TE, that we just talked about. The way that like I understand it is all about understanding like your own values, your own morals, your own integrity, your own feelings, especially like, and how they all relate, and what makes you as a person. Introverted feeling is always asking itself like, oh, how did this make me feel? How did that make me feel? Why did it make me feel that way? Going deeper into that, and then what does that tell me about a person? Introverted feeling wants to learn everything that it can about itself, so that it understands like itself from all these different types of layers. And then from there, you'll get, again, like certain desires. And so introverted feeling would be responsible for being like the engine behind the extroverted thinking vehicle. Introverted feeling says, I want that. Extroverted thinking is like, okay, well, how do we go and get it? And introverted feeling is also the part of us that's like, okay, well, while I'm going to try to get it in the extroverted thinking way, I want to still remain true to who I am. So no, even though dyeing my hair pink will make me more money, it's not true to who I am. So therefore, I will not do that. And that's, just like a silly example. But hey, there are a lot of, TE managers who will try to tell their FP singers or pop stars or whatever, like, hey, like pink hair is in right now, and you're gonna make a lot more money if you do this. And now it's up to the FP type to be like, okay, but like, is dyeing my hair pink authentic to who I am? / will I feel like in doing that, no matter how much money I get, TE, I'm selling my soul for it. So that's where like you can get a little bit of the clash with FI and TE, but then also you can get, the simpatico with them. Because if it's like, oh yeah, like I'd love to try out this new pink hairstyle and it just so happens to also get my goal, then boom. So I think that introverted feeling learns by kind of, well, I wanted to say actually, like, going out there and experimenting with who they are to be able to learn, like, okay, like most FI dominants, like introvert, so ISFP and INFP, for example, they might start off by being like, I have a very strong sense of who I am, what I feel, all of that. I know I don't like horses. But then, you take an ISFP out to a stable and they get in the SE of it. They're actually riding the horse. And then, they might still end up being like, yeah, like I said, I knew I didn't like horses, but before it was just some NI tertiary sort of like, I feel like I don't like horses based off of like what I've, been able to traject. But now that I've actually ridden a horse and I've been there and I've experienced the SE, I do not like horses. So I know that for sure. Or it's like, okay, now that I've actually been on the horse and everything, turns out I've learned more about myself. I do like horses, and I've learned more about myself in the sense that, yeah, I can be wrong about what I think I like and what I don't like and all of that. And ultimately, FI is like trying to learn more about itself. That's what I think in most cases. But Judy, having FI as an auxiliary function yourself and being an ENFP who, in my opinion, is deeply, very, very deeply integrated into your FI, what would you have to say about that or add on to it or even tweak with what I've said?
Firstly, I'm trying to very much shut down the part of my E that's now imagining all of the jobs that really would benefit from pink hair. But anyway, trying to not let that influence me right now. Firstly, I think there's a lot that math can teach you about yourself. Just by doing math, you will learn some humility. You will learn new viewpoints. You will learn to get out of your comfort zone. You will learn a lot of things. Read my book. You will learn what I've learned about
Read Judy's book.
So that's the first thing. However, I think especially with FI, instead of going the route of what can I learn about myself, rather tying math in with the values you already have. So a lot of FI users, for example, appreciate poetry. There's a reason for that. Poetry is very elegant. It can be very beautiful. It describes truths that you know very much are very true to your core, but in a very distinct way that speak to you so clearly that maybe some other form of literature does not. Stuff like that. Fun thing is, the same is true for math. It speaks about truth in a very succinct and very clear way, and also in a very elegant way. You can find a lot of elegance in math. I mean, you can do crude math, which is often what is done in school, where you just do a whole bunch of examples over and over and over again. Or you can go ever so slightly deeper and see the beauty in it through the arguments that tell you the truth behind it. So you can learn about Pythagoras' theorem just by doing 100 examples and just eventually being like, okay, fine, I'm bored of it. I'm just going to believe it's true now. Or you can read the proof and realize in a very beautifully and elegantly described way why this must always be true. So you can focus on that part of math. I know this takes maybe a little bit more literacy than just for the beginner. But if that is your goal on getting there, you can certainly find that, and you don't have to go to super high levels of math to find that beauty. Secondly, you may also enjoy learning math through autobiographies of mathematicians and how they feel about math. So if you read how mathematicians speak about math, the word beauty comes up more than the word math, usually.
Wow.
And there is a reason for that, because they see just those things that they appreciate so deeply about it, the love for it. One that you might really appreciate it as an EFP, IFP, whatever it might be, is A Mathematician's Apology by G.H. Hardy. He was a mathematician, and the early to middle 1900s, maybe even, I don't exactly remember when he died, but sometimes middle 1900s. Sorry, yeah, 1950-ish, I want to say. That's the 1900s, right? Not the 1800s. I always get confused with like the how many century it is. 20th century, 1900s, whatever. Makes no sense to me. And in this essay, it's just a long essay, he writes about what he loves about math, and he also laments the fact how he is not anymore, at least, but maybe never has been the greatest mathematician out there, and how that pains his soul. He does teach you a bit about math while you go through it, but you really learn about the person and about their deep feelings about it. And I think that would be a really good way for you to approach math, through the lived experiences of mathematicians. And basically, if you don't have the passion for it, borrow from their passion.
Interesting. That is very interesting, because I do know that according to Dario Nardi, FI users are the ones who, when they're being told a story, I think you said FI dominance, but I think that FI auxiliary also plays into it as well. Like when they're being told a story about a person's life and what they've been through and everything, they get into this flow state of like the area of their brain, like during brain scans and everything, is that's most activated is that listening part. And so they're like most interested in like, I want to, like, I'm learning about this person's soul right now.
Yeah.
And so seeing like why, like, oh, what makes this person so passionate about math? And even you just like the title, A Mathematician's Apology, it's like, what do you have to apologize for doing math for? I mean, if anything, math should be apologizing to you. No, I'm kidding. But like I feel like that's a very poetic title to even have. That it definitely even catches my attention. So I can imagine how for an FI user who is curious about like, why somebody might be passionate about math in general, they can be reading it and they can like you said, like borrow that passion from another person and see the necessity and beauty in that, and then continue to learn more about themselves through that, because like, oh wow, yeah, like I just don't relate to this person, or oh wow, I can actually see myself, like parts of myself in this person, and maybe that activates like their own passion in a way that they can personalize for themselves. So I can see how that does make math interesting for an FI user.
And I think especially mathematicians are amongst scientists the most idealistic, because you're this close to perfection, if you will, because no other science is perfect. All other sciences, and I don't even consider math to be a science, I consider it to be a philosophy, actually, talks about the real world, and they have to, do experiments, and everything they do has to tie in with what they measure, because that's what science is. But math is not like that. You're talking about concepts that exist for themselves and in themselves. And they are perfect in the sense that it's not approximate. It's not maybe this way or that way. It is provably true, or it's wrong. And it is exactly true.
Makes sense. Okay. I'm tracking with you. So then moving on to the next judging function, TI, introverted thinking. Introverted thinking, I think when we think about math, this is the function that most pops up. Introverted thinking is all about internal logic. It's all about what makes sense to me. Introverted thinking is, okay, regardless of what everybody else might think, this is what I think. I don't care if it's immoral. I don't care if it's gonna get me canceled or whatever. Like, I want to think for myself. I want to come to my own conclusions, and I want to come to that conclusion based off of the least bias possible. This is not to say that those who have introverted thinking are not biased and are never biased, but they are always looking for a more clean way to receive information and use that information to conclude things for themselves. And a good introverted thinking type is always trying to look back over their data. So it's like, okay, I had this belief 5 years ago. Let me revise this. And a really, really good introverted thinking type would not wait 5 years to revise that belief or revise that thought. They're always going to be trying to reevaluate. Okay, I've lived some more life. Do I still believe this thing, and why or why not? And let me try to remove as much as my self, as much as my bias or whatever as I humanly possibly can, so that I can get to the accurate answer. So with all of that said, introverted thinking, I think that's when we usually like get the people who are actually like, looking at very impersonal things, to be able to like, have all these equations and stuff like that. And I feel like that's why like TI is like very largely associated with math. So this might be like an easy one. But yeah, I would love to hear what your opinion is on that and anything that you feel like I might have missed in describing the function.
I think you're right. TI is probably the easiest one to get interested in math, and probably a lot of TI users are already naturally interested in math for just the very reason that TI works the way it does. It likes to have logical consistency. It likes to make sure that things make sense. And I mean, let's face it, math is very reliant on logic in the argumentation. So yeah, you will find that in math. Whenever you look at any argument, it will be logically consistent. Hopefully. It should not be published otherwise, and it's likely not it likely isn't published, because let's face it, if you put out an argument out there, there will be a peer review process. It won't be published, besides you writing it on your own website type situation. The nice thing about math is also that you can go as deep as you want. There are certain arguments that as a TI user, yes, you would think that that seems fine, but I want to go deeper to really make sure that this is logically coherent. There is no end to this with math. You can go as rigorous and as deep as you want. In fact, there is a group of mathematicians known as Nicolas Bourbaki, French mathematicians, that brought out a whole series of books that does exactly that, that makes sure that math, as described in those books, is completely devoid of any sort of intuition we have from the real world, and is purely deadly rigor, just rigor to the point where every single step is explained. So to a TI user, this may be very interesting. And fun fact, so the Nicolas Bourbaki was not known to be a group of mathematicians. It was thought of as a mathematician, but mathematicians are funny people, so they grouped themselves together, made this pseudonym, and had like this almost secret society that became ever bigger and ever bigger to the people that contributed towards that, until eventually the joke became stale, and they actually put out a eulogy for Nicolas Bourbaki. So now it's dead, but the books are still there.
Okay, interesting. Okay, and so I guess then I wanted to, like, going back to the question I asked earlier, what would make a formula a TE formula? Like what would make a formula more TE rather than TI? I don't even know why. I think maybe this is one of those introverted thinking things where I had never even thought about like, oh yeah, I just immediately thought formula, like, oh yeah, TI then, because it has the equation right there, or like, you know, literally like the formula, and you just kind of like plug in wherever the number is supposed to go, and then boom, you get the right answer sort of thing, or like coming up with that formula in general. But I guess, you know, I can start to conjecture why it would be TE, but I'm curious, like, are there such thing as like TI formulas, or are they all TE formulas, or yeah, pretty much like what made you say like a formula is TE in general?
Okay, maybe I've phrased this badly. I don't think a formula per se is TE. It's just a formula is a condensed way of writing down the concept.
Okay.
So instead of having for you to have to go through the example over and over again, you just use the formula instead, because it has essentially solved the method for you. That's what the formula is. It gives you the method. However, I think there are differences in how you can write formulas, and most of that is notation. Notation is a big thing in math. There are whole books written about math notation, and I know this sounds not like the maybe most exciting topic, but it really is. It's super exciting, because you can make or break the clarity of a formula with notation. So the one part of math that I used to work at, I used to work in abstract algebra, in particular group theory. Group theory has to do with symmetries, and the way that the part of math that I did was denoted was with something called bird tracks, which is a purely diagrammatic way of writing down formulae. And that just made concepts that in the traditional setting were basically just long lines of symbols with like subscripts and superscripts that were really, really hard to keep track of what is actually happening, super easy to see, because it was literally a diagram that expressed the exact same thing. There is a method of going about this and proving that this symbol means this line, and if it's curved this way, then it's this symbol instead, and such things. So there's a lot that goes into that translation process to make sure that it really does say the exact same thing, and is not just a picture that's representative of it in some way, but the exact same thing. But concepts can be expressed much easier with some notation than others. There's even, like, some mathematicians talk about proof by notation, because sometimes if you just change notation, it becomes so obvious that you no longer have to prove it, because just the notation does that for you. And there is neat notation, more clumsy notation. If any of you are familiar with the Einstein's formula for general relativity, there's like some R's in there with some mu news and some T with mu news and so on. That's a very condensed way of writing that formula. That R is essentially a list of symbols, where if you type in numbers for mu and nu, you're like, maybe R12 would be the symbol that's in that list in row 1, column 2.
Oh, gotcha.
Stuff like that.
Yeah.
So
Okay.
essentially each of that is a list, and you can write down an equation for each member of that list.
Right.
And then you get like this list, and it no longer becomes clear what's going on, because you're just overwhelmed with symbols. So that's a very condensed way of writing it. Maybe that's also a TI way. Maybe that's a T. I would maybe argue that's even an FI way, because it just brings out the most important part and makes it pretty.
Wow. I see. Well, in real time, I'm just letting that all sink in. And it's probably, a lot of this is probably going to hit me even more during the editing process. But to move on, while I guess everything is continuing to bang around in my NI, the last final judging function that we'll be talking about is extroverted feeling, also known as FE. From my experience and my opinion, extroverted feeling is all about interpersonal dynamics. It's all about, kind of like how TE is focused on the strength, the strong points and the weak points of a system. Extroverted feeling is interested in the strong points and the weak points of interpersonal dynamics of relationships. Everything that has to do with relationships, like two people, anything having to do with two people or more, extroverted feeling is very interested in. I believe that introverted feeling, by definition, is interested in intrapersonal, like it's going like internally, like the relationship with the self. So extroverted feeling is the relationship with others. And so extroverted feeling also by nature and obviously like not limited to, is all about like, okay, getting other people's needs met. It's all about fostering intimacy with other people. It's all about, you know, a lot of times understanding like the right buttons to push in the exact order to get an emotional, an expected emotional reaction, or an emotional result from a person or a group of people, etc. And with that being said, then extroverted feeling is also usually interested in like harmony, getting everybody on the same page. If introverted thinking is all about like, this is what I think, I don't care what anybody else thinks, and boom, boom, I want to go by my own, you know, thoughts and all that. Extroverted feeling is like, okay, I understand that we all have our own opinions on things. You have your political opinions, you have your religious opinions. Let's not talk about them. Or if we do talk about them, let's have a space that is safe to be able to share those things without us having rapport, be clashed. Now, of course, like this all depends on like the health of the extroverted feeling person. You'll have extroverted feeling that just says like, no, let's just not talk about it, like period, to keep the peace. And then you'll have extroverted feeling that's kind of like, actually, I do want us to talk about these things, but only if we're able to engage in them in a way that does not, does not rupture the harmony / does not allow us to like dislike each other in a way. So that being said, how would you relate extroverted feeling back to math? Especially because how I see it a lot of times, it's like, I think one of the reasons why extroverted feeling always comes with introverted thinking, for those who don't know. So that's the flip side point of it. So once again, if introverted thinking is all about this is what I think and boom, boom, extroverted feeling is like, okay, what does everybody think? And how can we like still, move as a society despite us all having our own opinions on things and all of that? How do we all still get along? What things do we share from our opinion so that for the, to connect, and what things do we not share so that it doesn't get in the way of intimacy and stuff like that? And so with TI users, as you said, I think that, yeah, it's like the easiest one to get people like interested in, or like when we think of math, we usually think of high TI. And so I would think by nature, lower TI is like, which to me makes sense. It's like, math, because math can seem so impersonal. It can seem so just zeros and ones and stuff like that at times. And so how do you get an extroverted feeling type who's interested in people and relationships and bettering those relationships and intimacy into math?
I would actually like to hear from you also what you think then, seeing that you are the dominant FE user. But the first thing that I would say is, remember, mathematicians are people. I know it doesn't always be that way, but they are. So why did these mathematicians actually go about solving that problem? What was the problem in their life that was posed to them that made them consider that math and actually go into it? What interpersonal dynamics did they have with each other that may have complicated the finding of a solution or may have brought it about? There is so much about what can be said about mathematicians and how they collaborate and how they did not collaborate, or how just their own interpersonal dynamics really sometimes hindered and sometimes evolved the finding of new theorems and the development of math. And I think it would really, really be to your best interest to go about it that way. So, for example, one of the first stories that I heard about mathematicians that I found super interesting was about this man called Évariste Galois, who was a French guy, and he's considered to be the father of group theory. So the part of math that I was doing research on, all about symmetries and so on. And he was concerned with solving something called the cubic equation. So if you know quadratic equations, that's something like that, just a little bit higher. And eventually he found a solution, if you will, although not maybe the one that you thought about. But the problem was he really haphazardly had to write down what he thought very, very quickly. and actually sent his findings off to another mathematician because the guy was 20 and he was stupid, as a lot of 20-year-olds are, and madly in love. And the next day he participated in a duel and unfortunately lost.
Oh, wow.
So he never finished his research because he was too in love, as a lot of people possibly are. But this is the kind of stuff that I'm talking about. Now mathematicians had to scramble and be like, okay, so we have an almost solution here. How can we make this into a solution, like talk to each other and, you know, get into the nitty-gritty of stuff? That's the sort of stuff I'm talking about. Or in my book, I write about actually how the cubic equation came about, and which was a very interesting time in Italy in like the 16th century, where mathematicians had mathematical duels. So they were constantly posing problems to each other, and like this was like involving public shaming and a lot of stuff. This was dirty stuff that was happening, and how they were actually maybe not very much collaborating on that account, because they constantly had to keep an ace up their sleeves to make sure that they can dominate in a duel were they ever challenged to one type situation. And stuff like this. There's a lot of interesting social dynamics that happens with mathematicians, and how, you know, they went about their problem solving, and even why they were even considering these problems at the time. So I would recommend actually maybe going via the history of math, reading again about the mathematicians and the social dynamics they participated in. How, for example, the Pythagoreans were so incredibly taken aback, is probably a understatement, by the fact that the square root of 2 is not a rational number, that lots of them committed mass suicide. Stuff like that. Why the heck did that come about? That might be interesting to you as an FE user. And I think, especially as an FE user, study groups are a good idea. Don't just study on your own. Have a study group.
Yes. Let's outsource our TI.
Exactly. Yes, exactly.
Guys, to help us all, with our math, how about we all meet up and discuss this thing, and like, let's do the work together and all of that. No, that it's funny because even as you were speaking, again, I was thinking of the teacher from Dead Poets Society, and how like you were actually captivating me with some of the stories that you were just telling me, and I was like picturing like math duels, like, and all of that. I'm like, oh, interesting. Yeah, I wonder what, like, how society must have had to look like interpersonally for that to like have been a thing at the time. And
stressful,
you know, even like
stressful.
And like you even said, like, they got like really dirty. It's like, who allowed this to happen? But then, you know, like, I guess you think of stuff like rap battles even, and it's like, you know, rap battles can get pretty dirty and everything too. But even then there's like a social understanding that like, oh, it's just all performative. And in this, you know, field, the nature is to try to rip you to shreds with my words poetically. But I don't really mean most of what I'm saying, unless if I don't like you, you know? And so I think that maybe there's like some parameters there too with the math duels, but also maybe there was not. Maybe there was no.
That was really to destroy the other person. Like, we were talking about the person who won got the other one's job, and the first one lost their job and lost their sponsorship by rich people that were interested in scholars, stuff like this. So this had actual consequences. This is not just a friendly duel.
That is a very, what I would consider, TE cutthroat approach. Like getting up the scale and the FI desire of, I want to get up there, even if it's at the expense, because, you know, the TE might be lower or something like that. I don't know. I mean, the FI might be lower at that point because it's like the TE is overpowering. So it's like, even at the expense of this other person's livelihood and humanity, because I'm prioritizing my self-preservation. And yeah, I guess as an FE user, I'm like, wait, guys.
But your FE is interested enough in the story to actually analyze it now.
Yeah, exactly. Because now I'm thinking like, well, how could we have done this in a better way? That definitely is like something that's like interesting, because then obviously one would have to like learn what the math was that they were like dueling over and everything, and why the
why that math? Why
so,
did it?
Yeah.
Why was that problem such a big deal that people would duel over it type situation?
Right.
What was this a society like?
Yes.
And you will learn that if you read about it.
Yes.
And learn the context of it.
Exactly. In your book, do you also go over the context of why people were committing suicide?
Not this particular example, because eventually my book had to find an end. But the whole math duel thing, what the problem was, why it was such a big deal, why people were so riled up about it, that I do go over.
Okay, got you. So then for those who are watching and are like, wait, suicide, what? Do you mind shedding some light on that as a final teaser and reward for even watching this far?
Sure, and maybe for a part 2 of my book, who knows?
Right.
Essentially, because back then, math was closer to religion than it was a science. Back then, people thought of numbers as something very divine. And to an extent, I would agree with that. I think there is something very divine about it. And that goes more into the NI realm of what is a number. But anyways. And then somebody wrote down the square root of 2, which comes about quite naturally if you think about the Pythagorean theorem. You have a triangle that has side length 1, side length 1. What's this length? Well, it's 1 squared plus 1 squared, 2 squared, 2. So the square root of that, square root 2, is just the length of this. That's all that it is. But seeing that whole numbers like 1, 2, 3, 4, 5, and so on were considered divine, Pythagoreans back at the time thought that every number could be written as either a whole number or a fraction, as in, a half, a third, 2/3, whatever it might be. And when somebody proved, someone who sounds like hippopotamus, but that's not his name, and his actual name eludes me right now, and it's very annoying, but very, very close to that. No, it really sounds like hippomus, something like that. Anyways, when he proved, or at least came forth rather publicly with the proof that the square root of 2 cannot be written as a number like this, the world just fell apart for them, because this was a shape that they were familiar with, that was clearly a divine shape, and yet the solution was not a divine number in their sense. And they just didn't know how to deal with that. That basically broke their worldview completely. It was a paradigm shift, if you will. As so often happens in math. When there's a big discovery, it is essentially a paradigm shift, because you have to rethink how you view the world.
I see. Sheesh. That's disappointing for a lot of them. I can definitely tell. But wow. Okay. And as I process all of that, I'd like to say thank you, Judy, for being a guest on this channel. For those who don't know, and probably I should have said this in the beginning, I actually also was a guest on Judy's podcast. We talked about the Barbie movie when it came out. I'm going to link that in the description as well if you guys are interested in checking that out. So, here you got to hear about math. There you get to hear more about our thoughts on, everything that the Barbie movie had to pretty much tackle, which I think is still relevant today. Despite it having been like a year or two since the movie's come out and everything. And I'm curious, Judy, so where would you say people can find your book? And also, what would you like for people to be able to receive from your book?
It will be available on Amazon from 1st of September. So depending on when this video will be posted, it may already be out. And basically what I would love for people to get out is if they had any sort of negative experiences with math that made them feel lesser about themselves in any shape or form. like made I can't do math, or I'm not good enough to do math, whatever it might be. That I hope that after reading the book, and you don't have to understand everything that's in the book, that's totally okay. Some of the things are hard, and that's also okay to experience math that way. But I hope that you come out of the book thinking that not that you are not good enough, or not that it's lesser, or you're less in any way or something along those lines, but rather that you think of yourself as someone who can do math if they choose to, and that maybe you can even find some joy in pursuing math further.
That's beautiful. Thank you again, Judy. I really, really appreciate it.
Thanks so much for having me. This was a blast.
Yeah, I definitely agree. And I think this is going to help a lot of people. And I really do think that your book, from what I was able to read, I heard your voice throughout the book, like throughout the chapter and everything. And I was able to see and your humor really shown through the book. So again, guys, I really, really recommend y'all getting this book. Whether you're done with math and everything, and done as in class done, because math is everywhere apparently. But also if you have children, you're okay, you want to help them with math and everything, or you're trying to understand how to help other people. If you're a math teacher and you're oh, I didn't even know about personality typology and everything like that, and Judy goes through in the book okay, this is how to understand what types are using these functions. Today we went over the functions, but from there you're able to now put together mathematically okay, if this person has NI, then they must have SE, and if this person has FE, then they must have TI. So they're probably an STP or an NFJ. Then you just figure that out, and from there you're able to help them on okay, this is how I might be able to approach them with math. Who knows? So the book, I think, could be extremely helpful. I highly recommend that you guys check it out. I'll have the link in the description and everything. And Judy, if people wanted to reach out to you and tell you how much they absolutely loved your book, and just how much you might have helped them with their children or with their classes or anything it might be, are they able to? And if so, how can they reach you?
I mean, firstly, if you were or if you found it really helpful, I would love it if you leave a review on Amazon, because that will help me reach other people and hopefully help them as well. But if you want to reach out to me personally, I have a website called geeksinspire.com. You can find my details there. I also have a Instagram by the name of Geeks Inspire, and a very, very inactive YouTube channel, which maybe I will get around to, also called Geeks Inspire. Currently one video there, so maybe not the place to be, but definitely on my website or on Instagram, you can find me, reach out to me. I'd love to hear from you, and I'd really, really love to hear how the book helped you, and maybe even about your math journey, if you're willing to share that. I would love to know more about that.
Beautiful. All right, well, thanks once more, Judy, and thanks everybody for watching this far, and don't forget, you matter. Done. Thank you for taking the time to watch that video, and if you enjoyed that, please like and subscribe. It actually really helps out my channel a lot, so that more people who actually care about what I want to say can actually find me a lot more easier. Also, if you did enjoy it, then maybe you'll enjoy a lot of my other content as well, so be sure to check out some of my playlists where you'll be able to find a lot of my older videos and older content. And last but not least, if you would like any profiling sessions or coaching sessions, be sure to check out denzelmensah.com, where you'll be able to book me and you'll see the rest of my services. But thanks again, and have a great day.